Hi, this is Mr. Miller, and in this video, we're going to go over the solutions to the practice mastery quiz for vertex form. All right, here we go. This begins with identifying the vertex of each of the parabolas below. So that's a matter of understanding how they've been shifted. This first parabola here, since it's x plus 4, means that the graph has been shifted to the left, and this minus 5 means it's been shifted down. So it's been shifted to the left 4 and down 5, which means that the vertex would be at -4, -5. For B, this has been shifted to the right 2 and up 7. So the vertex of our parabola would be 2, 7. This first graph, or sorry, part C here, this hasn't been shifted at all. It's not x plus anything or x minus anything, which means that the x-coordinate of the vertex is still 0. It has been shifted up 4 though, so the vertex would be at 0, 4. For problem number 2, it says, is the following parabola concave up or concave down? Explain how you know based on the value of A. Well, A is 1/2, which is greater than 0, which means this is concave up. This is an upward parabola. Okay, if A were less than 0, it would be downward. All right, part 3 says, find the equation for the line of symmetry of the parabola y equals -4 times x minus 6 squared plus 9. Well, the line of symmetry passes through, is a vertical line that passes through the vertex. This parabola has vertex at 6, 9, and the vertical line is the line that has x equal to 6. All right, x equals a number is an equation for a vertical line, and we want x to equal 6, so it passes through the vertex of the parabola. Number 4, which equation has vertex at the origin? Well, this first one hasn't been shifted left or right, but it's been shifted up 2, so it's not that one. C has been shifted left 2, so it's not that one. This has been shifted right 1 and up 1, it's not that one. It turns out B. This parabola has been stretched. A is 2, but it hasn't been shifted left or right. Okay, in problem 5, we're asked to graph this parabola. We're to label the vertex and find 4 other points on the curve. So this parabola has been shifted to the right 4 and up 5, so the vertex is 4, 5. So that's the most important point to get right on the graph, and 4, 5 lies about there. Now, we're supposed to label 4 other curves. So we're going to put in 2 values for x on the right of the vertex and 2 values on the left. When I put in 5, I got 3. So when x equals 5, y equals 3. And when x equals 6, y equals -3. So remember, we find points close to the vertex because at other points, function gets too large. All right, at 3, it's +3, so I'm going to mark that point right here. And at 2, it's -3, which is right here. All right, the next step would just be to kind of draw it in, which is a little hard with a digital pen, but our parabola would kind of look like that. For problem number 6, it says, which sequence of transformations describes how the graph of y equals 1/2 x minus 4 squared minus 5 is transformed from the parent graph of y equals x squared. So the idea is we're starting with y equals x squared, and we're step by step building the parabola we have. Okay, well, maybe we can use a little elimination. Vertical stretch by 2? No, A is 1/2, so that's not a vertical stretch at all. That's a vertical shrink, and it's certainly not a reflection. So the fact that A is 1/2 eliminates A and C. B says shift right 4. That makes sense. This is x minus 4 and down 5. The correct answer is B. C is going the wrong way with the horizontal shift. Okay, so suppose the equation is graphed. How does changing value of A from 2 to 4 affect the graph? Well, it increases the vertical stretch, so it makes it thinner. Or actually, the word they're using is narrower. So the answer would be narrower because we're increasing the vertical stretch. Okay, in problem 8, we're shifting to writing equations for parabolas. It says a parabola has vertex 1, 4, and goes through the point 3, 0. Write an equation. All right, so we're going to use vertex form here. A times x minus h squared plus k. Okay, so I'm going to put in the vertex here. H is 1, k is 4. And so we get y equals a, we don't know that yet, x minus 1 squared plus 4. So to find a, we're going to use the point here, 3, 0. So we're going to put 3 in for x and 0 in for y. So we get 0 equals a times 3 minus 1 squared plus 4. 3 minus 1 squared is just 4, so we get 0 equals 4a plus 4. If I subtract 4 from both sides, I'm going to get negative 4 equals 4a. If I divide by 4, I'm going to get negative 1 equals a. So we're going to take that and we're going to put that right here, and then we have the equation. So we have y equals negative 1 x minus 1 squared plus 4. That's the final equation for that parabola. Okay, and problem number 9, same thing. We're just given a graph. So this is going to look very similar because we just need the vertex, which is at 2, negative 4. And we can use any of these other points. I like positive points, so I'll probably use that one, which is at 8, 5. But you can use any of the other points. So here we go. We're going to start with vertex form. Then I'm going to put in h and k, which is 2 and negative 4. So we get y equals a x minus 2 squared minus 4. And let's put in the point. So 8 goes in for x, 5 goes in for y. Um, 8 minus 2 is 6, squared is 36, so we get 5 equals 36a minus 4. If I add 4, I get 9 is 36a. And if I divide, I get a is equal to 9 over 36, which is actually 1/4. So here goes the equation. Y equals 1/4, that's a, x minus 2 squared minus 4. For question number 10, again, we're writing an equation for a parabola. This time we're told that it has a minimum value at negative 2 at x equals 3. So that tells me it's kind of an upward parabola, and the vertex occurs when x equals 3, and the minimum value, that's the y-coordinate, is negative 2. So we just have to write the equation of any parabola that has that vertex and opens up. So how about this? Y equals, let's say, 1. Any positive value for a will cause it to be opening up. X minus 3 squared plus k, so minus 2. All right, so on this one, we use vertex form again. We put in h and k, and a just had to be greater than 0. Any value would work. Okay, we're getting into the last part of the quiz here. So we're going to do some arithmetic with complex numbers. We learned that when we add them, we just combine like terms. 3 plus 5, that's adding the real number part, is 8. And if I kind of combine the imaginary part, 2i plus a negative 4i is negative 2i. Okay, that's it. On here, we're going to use FOIL. If I multiply the first, 2 times 4 is 8. And then the outer, 2 times minus I, is minus 2I. When I multiply the inner, 4 times 6I is 24I. And when I multiply the last, the last would be here. It would be 6I times minus I would be minus 6I squared. Okay, time to simplify. I have 8 minus 2 plus 24 is 22I. Remember that I squared is negative 1, so this is really negative 6 times negative 1, which is plus 6. And finally, if I combine the 8 and the 6, I get 14 plus 22I. All right, we're almost done. In question 12 here, find the zeros of this parabola. Express your answers in exact form as well as decimal approximations. Well, when I put 0 in for y, we get 0 equals negative 3 times x plus 1 squared plus 12. And we want to solve for x. We're trying to figure out what values of x make the whole function equal to 0. So if we subtract 12 from both sides, we get this. And if I divide by negative 3, negative 12 divided by negative 3 is positive 4. I'm going to take plus or minus the square root equals x plus 1. And if I subtract 1, I get x equals negative 1 plus or minus square root of 4. Okay, square root of 4 is just 2. So this is negative 1 plus or minus 2. Actually, there's not going to be any decimals here at all. So I get x equals negative 1 plus 2, which is 1, or negative 1 minus 2, which is negative 3. There are two answers. So they want exact form. That's actually exact, and it's the decimal approximation. But remember, usually the square root cannot be simplified, so the exact form would just have this with the square root. The decimal would be what you get if you enter it in your calculator. All right, last one. It says find the complex zero. So that's a clue that this might involve I. So here we go. 0 equals x minus 2 squared plus 9. Subtract 9 on both sides. We get negative 9 equals x minus 2 squared. We're ready for the square root. There's nothing to divide by, so we get plus or minus square root of negative 9 equals x minus 2. If I add 2 on both sides, I get 2 plus or minus the square root of negative 9. All right, we got a little simplifying to do. So this is equal to 2 plus or minus the square root of 9 times I. So remember, I can break this up in the square root of 9 and the square root of negative 1. The square root of negative 1 is I. Okay, so that's where this comes from. And now I can take the square root of 9. The square root of 9 is 3. So I get 2 plus or minus 3I. Those are the two complex numbers that, when you substitute in for x, would actually make the function 0. All right, that's the practice quiz. Good luck.